Hello students, welcome to Inside Physics. Today we will discuss Coulomb's law in electrostatics chapter. See, before going to Coulomb's law, we will see what is law of conservation of charge. Actually, what is a charge? It is a property of an object by which it produces or experiences electric and magnetic effects. See, law of conservation of charge tells us that charge cannot be neither created nor destroyed, but it will move from one object to another object. Okay, this is called law of conservation of energy. This can be observed in nuclear, chemical and molecular reactions. The total charge before a nuclear reaction or a chemical reaction is equal to total charge after the chemical reaction. Okay, in this way we can say that charge is conserved. The total charge on a neutral body is always constant. The total charge on a neutral body is always constant. Okay, so here this is what law of conservation of charge. This is similar to law of conservation of energy in kinematics. So next we will see what is electrification. What is electrification? Electrification is a process by which we charge the bodies or we make the bodies to get charged. In this process of electrification, generally we have three methods, that is electrification have three methods, that is by friction, and we can do electrification another method called conduction. Okay, and C by induction. These are the three methods that by which we can electrify an object. We know friction is rubbing an object with another object, thereby because of frictional force the electrons move from one body to another body, and where the electrons are moving from one body to another body, in this process one body will become positive and the second body will become negative. In this way, by frictional process we can electrify an object. And second one, conduction. Conduction is a process by which we can charge a body by conducting through a wire or something like a conductor. Next one, induction. Induction is a process in which there is no physical contact actually, and when the charged bodies have come close to each other, then the induction process will come into play and one body induces the opposite charge to the other body. This is called induction. We will see this in conduction process there will be a physical contact. In induction there will not be any physical contact. We will see how an induction process will work. If there are two charged bodies, this is positively charged, this is negatively charged body. Okay, or we can say this as a neutral body also. If it is a neutral body and the charged body will be coming close to this neutral body, then on the nearer side the opposite charge will be gained on the nearer side of this charged body because of the attraction, and the farther side will have the opposite side to this negative charge. That means this side will become positive charge. This is the process of induction without any physical contact, that is induction of the charge. Okay. See, we will see one question here. Are there any objects that can attract each other having similar charges on them? See, is there any two bodies which are having similar charges can attract each other? The answer is yes. See, if there are two similar bodies having, suppose, positive charge on them, see, when they have come closer to each other, see, this positively charged body will attract the electrons in the second body to this side, and the protons will be moving to other side. So in this process, if the attraction between these two bodies overcomes the repulsion between these two bodies, then we can say that the law of attraction has overcome the repulsion between these two bodies. So we can say that two similarly charged bodies can attract each other. In this way we can take negatively charged also. Okay. So next we will move to Coulomb's law. So what is Coulomb's law? Coulomb's law states that the attraction or repulsion between any 2 point static charges is equal to directly proportional to multiple of the charges and inversely proportional to square of the distance between the two charges. We can write Coulomb's law as F is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. This is the formula for Coulomb's law. So by this we can state the Coulomb's law, in which the force is inversely proportional to square of the distance between these 2 point charges. See, if Q1 and Q2 are 2 point charges, Q1 and Q2 are 2 point charges, and R is the distance between them. So the force of attraction or repulsion, when these are two similar charges, the force will be a repulsive one. When these are oppositely charged, that means plus and minus, the force will be an attractive force. Either of them, either repulsion or attraction, the force of attraction or repulsion is given by this formula. Okay. See, in this, the epsilon naught is called permittivity of free space. Permittivity of free space. The value of epsilon naught is given by 8.857 into 10 to the power of minus 12 coulomb per Newton meter square, or farad per meter. See, permittivity of free space or air, and overall this value of 1 by 4 pi epsilon naught can be written as 9 into 10 to the power of 9 into units is Newton meter square per Coulomb square. This value we can use in the problems that we'll do in the next classes. Okay. See, this is what Coulomb's law says, and Coulomb force is a central force, and the charges Q1 and Q2 forms an action-reaction pair in the form of Coulomb's law. That means if this charge is applying a force on this charge, in the same way this charge applies an opposite charge on this charge. In this way they form the action reaction pair, thereby obeying Newton's third law. So Coulomb force is a central force, and just like the gravitational force, this Coulomb force can be compared to gravitational force also. Okay, so when we compare this Coulomb force with the gravitational force, these two forces can be compared with the relation 10 to the power of 36 Fg. That means gravitational force is equal to Fe, electrical force. See, the gravitational force and electrical force can be compared with this relation. Okay, so this is about Coulomb's law, and next we will move to permittivity of a medium. Now we will see what is permittivity of a medium. What is permittivity? It is a property of the medium by which it actually opposes the flow of charge. See, that is called permittivity. Permittivity is a definition where the medium has some opposes to the flow of charge or electrical lines of force. That is called permittivity. And by this permittivity we can state the relative permittivity of a medium also. What is relative permittivity? Relative permittivity says the permittivity of a medium with respect to permittivity of air or free space. That means, see, that the ratio of permittivity of medium to permittivity of free space, epsilon by epsilon naught. And relative permittivity can also be stated as it is the ratio of the force of attraction or repulsion between two charges in air or free space to the force of attraction or repulsion between the two charges in any medium. That means it can also be written as F naught by F is equal to, we can write it as epsilon R. That means permittivity of medium, relative permittivity, is denoted by epsilon R. Okay, so with this we can write the Coulomb's law in this form as, for air or free space we know that 1 by 4 pi epsilon naught q1 q2 by r square. See, if these two charges are put in a medium of dielectric constant K, see, this epsilon R relative permittivity is also called and represented, K is also called dielectric constant of a medium. Dielectric constant of a medium is represented by permittivity of a medium to permittivity of free space. So in this way Coulomb's law can be written as 1 by K into 4 pi epsilon naught q1 q2 by r square. We can write it here as epsilon only, 1 by 4 in a medium. So here 1 by K dielectric constant of a medium, epsilon naught is permittivity of free space. Okay, so here for air or vacuum we can take K is equal to 1, and for a good conductors like metals K becomes infinity. That means if a glass slab is placed between any two charges, that the force of attraction or repulsion will decrease because the dielectric constant will be more. If a good conductor like metals are placed in between those two charges, then K becomes infinity and the force of attraction or repulsion becomes 0, because for metals and good conductors K is equal to infinity. Okay, so by this formula we will have some implications, 2 or 3 implications we have with this formula. We will see what are those. See, F is equal to 1 by K 4 pi epsilon naught Q1 Q2 by R square. See, if these two charges are put in different mediums, that means one medium having dielectric constant K1 and the second medium having a dielectric constant K2, two charges Q1 and Q2 are put in two different mediums with dielectric constant K1 and K2. These forces will also become F1 and F2. In this case, we can write that the first implication F1 K1 is equal to F2 K2. Okay, so and the second implication, if these two charges are put in the same medium with different distances between them, the charges put in the same medium with different distances between the two charges, then this equation we can write F1 d1 square is equal to F2 d2 square. Okay, and the third implication will be, if two set of charges Q1 dash, Q2 dash and Q1 Q2 are put in the same medium, okay, with same distance between them, then the third implication we can write by these formulas is Q1 Q2. This will be the third implication. And the fourth one, see, if these two charges put in the two different mediums with two different distances between them, okay, two charges put in two different mediums with two different distances between them, and the force of attraction or repulsion is same in these cases. So thereby we can write the fourth implication as K1 R1 square is equal to K2 R2 square. See, here D1 D2 or R1 R2 both are same. Here the distance is we have taken as D1 and here we have taken as R1. So both represent the distance between the charges only. So in this way we can write the four implications of Coulomb's law, and thereby the Coulomb's law is one of the most important laws in electrical charges and fields, that means electrostatics, the study of static charges. Okay, that's it for now. In the next class we will see some more topics in electrostatics.